All right. So we should finish early. So if you have any questions at the end, you can drop them in the chat as well. So I don't even know why this was a Regents question, to be honest. A geometry Regents question. It's more of an algebra question. Actually, more of a physics question. I don't know. In the year 2020, the village of Depew, New York, I don't know where that is, had an area of 5.1 square miles and a population of 15,069. In the same year, the village of Lancaster had an area of 2.7 miles and a population of 10,087. Which population had the larger population density in 2020? Justify your answer. So what you have to do here is basically population density is going to be the number of people per square mile. So all you're going to do is you're going to take the number of people in each town and divide it by the square miles, and that will give you the population density. So for the most part, I think most students overall did okay on this question. I'm going to talk about the grading in a second. So first of all, we had Depew. So we have city, people, area, and then density. So, and you're going to people divided by area. So in Depew, 15,069 divided by 5.1 square miles is going to be, well, here, let's just set up the other one first, and then Lancaster. We had 10,087 and 2.7. And we're going to divide those. So 15,069 divided by 5.1 is 2,955 roughly. 10,087 divided by 2.7 is 3736. So Lancaster is the answer. Okay, if you just wrote down Lancaster and showed no work, you got 0 points. If, let's say you did your calculations, because I graded this question, if you did your calculations completely wrong and still like got two numbers and said, based on the numbers you got, and Depew was your answer or Lancaster was your answer, even based on wrong calculations, you got 1 point. That's what I'm trying to stress to show your work. So again, show your work. Even if your work was completely wrong, it was very easy to get a point on this. This one, students across the city, though, from the ones that I was grading, struggled with this question, mainly because they forgot the exterior angle theorem. There's two ways to do this. One is to remember that the exterior angle, so this angle on the outside, equals these two combined on the inside. The other thing you could have done is you could have said, hey, this angle here on the inside has to be this one, has to be 180 minus 6x minus 23, right? Because they're supplementary to each other. And then you could have done it, and then you could have added all three angles together and said they were equal to 180, right? So let's go ahead and do that. So it's going to be 180 minus, in parentheses, 6x minus 23. Is everybody okay with that? That's this angle here. Okay, assume yes. And then I'm going to add the other two angles, 3x minus 22 plus 4x minus 18. And those three angles have to all equal 180 degrees. The other thing you could have done, and I'm just going to write it up here, is you could have said 6x minus 23 equals 3x minus 22 plus 4x minus 18. That is another approach. That's if you're going to use the exterior angle theorem. Oh, let's just go ahead and do it the way I was working on. All right, so 180 minus 6x minus 23. So that's the same as 180, because I have to kind of distribute that negative sign, right? As minus 6x plus 23 plus 3x minus 22 plus 4x minus 18 all equals 180. Now what do I have to do? Combine like terms. So we have all of these constants or numbers, and we have these, whoops, x terms. Let's go ahead and combine those. So we have 180 plus 23 minus 22 minus 18. So that's 181. Now let's just go ahead and add those in my calculator so I don't make any mental math mistakes. 180 plus 23 minus 22 minus 18. So 163 minus 6x plus 3x plus 4x. That's plus x equals 180, right? So then you subtract 163 from both sides, and you should get 180 minus 163. Oh my goodness. 17. So x is 17. So there were a lot of struggles on that one, I noticed when I was creating that one. There's a lot of students couldn't figure out like how to. Oh, wait, and I'm not even done, right? So I need to find the measure of ACB. So if you found x is 17, you got 1 point. But we actually need to find the measure of angle ACB. So I just need to plug that in, right? So it's 180. Whoops. 180 minus, in parentheses, 6 times 17 minus 23, right? So what is 6 times 17? Let's bring that calculator back. So 6 times 17, that is 102, minus 23, 79, and I'm going to subtract that from 180. So 180 minus 79 is 101. So the measure of angle ACB equals 101. Make sure I did that right. Let's take a look at my solution guide. Oh, these are the multiple choice solutions. We'll come back to this. That's much neater than what I did just with you. Yep, it's a 101. So I did it a little differently on the solution guide. As you can see, I use the exterior angle theorem. So either way, you can get to the same solution. Okay, keep on chugging. Parallelogram ABCD is shown below. Use a compass and a straight edge to construct the altitude from point A to DC. Leave all construction marks. So I'm going to show you what I did on the solution guide and just talk you through it. Basically, what I did, on construction. So I basically extended this line segment here and then said, hey, let me go ahead and make a circle centered at A. Because I want to find this altitude here. So I just made a circle centered at A, and then I found these 2 points that intersected the base of that parallelogram. Then what I did from those 2 points is I just created new circles, these that were the same size, this one and that one, and found these 2 intersections here, which gave me the perpendicular bisector of, basically I wanted to find the perpendicular bisector of this line segment. That's really what I was doing. And that gives me the height. That was a pretty tricky construction, I thought, actually. Again, if you want, like, if a student just did like kind of like this part and then kind of like guesstimated like where this thing was going to be, you got like a point out of that. So, just try and show some construction marks, throw in some perpendicular bisectors. You might get some partial credit there. Again, I wouldn't stress too much about the construction question. It's only 2 points out of 32. So, your goal should be to like get at least like, I'd say, probably 16 points out of 32. So, try and get, half of them. So it's not really the end of the world if you don't get that one. Okay. This one I thought was super easy, and I thought when I was grading this, I saw a lot of clever solutions. One solution, which is the strategy I always kind of teach, is, just make the rectangle around and then find the area of each of these triangles. To find the area of the whole rectangle, find the area of the triangles and subtract them. And then that leaves you with that quadrilateral there. This one, since it was a fairly straightforward, just kind of like rhombus situation, there were a couple ways you could do it. You could just like find the area of this triangle and then double it, right? Or you could find the area of, say, like this triangle and double it. A lot of different ways you could have used, I saw some students use the shoelace method, which I showed you last time. You can do that. This is the easiest thing for me, I think, is to just think about like this triangle here. I'm going to show you. Because it's a rhombus, all 4 of these triangles inside the triangle, inside the rhombus are going to be the same. So if you find the area of this one, and then we have, these as well. We have 4 of these triangles. If you just find one of them and then you just multiply by 4. So the height of this thing, height of this triangle is 3, right? And then 1, 2, 3. And the base is 5. Let me erase these other numbers because I don't want to confuse everybody. So the length of this base is 1, 2, 3, 4, 5. And the height is 1, 2, 3. So the area of a triangle, which you definitely have to know, is 1/2 length of the base times the length of the height. So the area is going to be 1/2 3 times 5. So what is that? Well, 15 times 1/2 is 7.5. So this triangle is 7.5, this triangle is 7.5, this triangle is 7.5, and this triangle is 7.5. What is the total area? 30. All right. Again, this one I thought was fairly straightforward as long as you remembered the fun fact about right triangles. So if you have a right triangle, the acute angles have the relationship of sine of 3x minus 7 equals the cosine of x plus 1. So what do we know about the acute angles, which are these angles here? They're less than 90. They're so acute, they're so small. They actually have to add up to 90 degrees. So if we know they have to add up to 90 degrees, these two expressions also have to add up to 90 degrees. There are other ways you could solve this. You could kind of do a little guess and check, but the easiest thing to do is 3x minus 7 plus x plus 1 equals 90. Okay, we'll combine like terms, and you're going to get 4x minus 6 equals 90. Add 6 to both sides. 4x equals 96. Divide by 4, and you get 24. I can't do that. 96 divided by 4. Oh, 24. I was right. X equals 24. They love these questions. So you just have to remember that these two angles are going to add up to 90 degrees, the sine and the cosine. If it's multiple choice, I mean, you just plug in the answer choices and see which ones work. But remember, I'd say the most common mistake we saw is students would set these two things equal to each other. If you did that and you found something, I think you got partial credit. So okay, number 30. There were a decent number of circle questions on this Regents exam, I thought. There was one circle equation question, right? There was a multiple choice circle equation question. There was that other multiple choice question. And then now we have this one. By the way, they love these questions on the SAT as well. So when you're taking the PSAT next year, and I guess you'll take the SAT, many of you will take the SAT in the spring as well. So we want to find the measure of arc MB. Want to find out how long that is. So in order to do that, we basically just need the circumference, and this is 20. And so circumference is 2 times pi times r. The arc is going to be the circumference times the angle over 360. And the radius is 20. So, and we just need to leave it in terms of pi, so we don't need to actually multiply by pi. We just need to simplify all this stuff. So we can plug it into our calculator, but I'm just going to go ahead and simplify it. So 36 over 360 is 1 over 10. And then 2 times 20 is 40. And then 40 divided by 10 is 4. There you go. There's your answer. 4 pi. Okay. And here we go. 31. Another similar triangle question. So, and we just have to explain why they're similar. We don't even have to really do much. So what I'm going to do, like I do every single time, is go ahead and stack the letters. Triangle ELM is similar to triangle ANT. Then I just need to say, okay, well, EL over AN equals, so the first two over the first two, the last two over the last two, the first and last over the first and last, equals LM over NT equals EM over AT. And if you didn't know what to explain, but you just at least wrote this down, I'm going to show you. EL is 9, AN is 6, LM is 8.4, 5.6 is NT, and then ME or EM is 6, and AT is 4. If you wrote this down, you got 1 point out of 2. You didn't explain anything, you just wrote down some equivalent ratios, you got half credit. So you actually didn't need to even explain anything to get half credit. What do all of those things equal, by the way? Well, let's plug them into our calculator. So 9 divided by 6, 1.5. 8.4 divided by 5.6, 1.5. 6 divided by 4, 1.5. That's 3 over 2. So these all equal 3 over 2. So what I would say is, why are they similar? Well, the two triangles sides are proportional. Therefore, the triangles are similar. And all you had to say was they were proportional, and you would have gotten full credit. I'm just going a little extra here. By side, 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 similarity. That was my dog. She wants dinner. Or you could even have said they have the same scale factor. Something like that. So there you go. Part 3. So those were all 2-point questions. These are all 4-point questions. Number 32 wasn't too bad. Here, let me show you one thing here. I'm going to go back to classroom. So if you go to this fun stuff here, past Regents exams, if you go to this website, it has, all the past exams in here, and go to the model response set. This has like all this fun stuff in here. So like you can see like what other what a correct answer is. And so here I wanted to show you this one. 4 pi. Yep. Correct response. Did that one. But the nice thing is it shows you like, ooh, that was a cool diagram. Um, yeah, so yeah, they compared the ratios of 2 of the sides, not 3 of the sides. So they got a point for that. Um, again, so this is interesting. They got all their calculations wrong. And so they said the triangles are not similar, even though so all of their calculations are wrong. And then they said the triangles are not similar. They still got half credit for that. So, I mean, that's pretty amazing, right? So again, it's not difficult to get points on these. You just need to show your work. Okay, this one here, I wanted to show you. So um, here are all the correct responses, but it's really easy to get points. Here, let me show you one other thing. If you go to the the rating guide, this tells you like this is like the grading rubric for each of these things. So if you like say that container 3 is correct, or if you show, that like here you find the volume of all 3 containers, but no further work is shown, you get 3 points. You get 2 containers, you get 2 points. So again, it's just a matter of like showing some work and getting some partial credit. So let's go through each one of these. So the first one is a square prism with a base length of 4 and a height of 7.5. So if it's a square prism, let me go ahead and kind of sketch that. Something like, something like that. Let me make this one dotted. Okay, so it's kind of a square prism. And then so each of these side lengths are 4 of the base. And then the height of this thing is 7.5. So this is container 1. So the volume is going to be the area of the base times the height. Here's our height. The area of the base is going to be 4 times 4 because it's a square. So the area of the base is 16. Volume is going to be 16 times 7.5. What is that? 120. So this is container 1. 1 point for getting 1 container right. Container 2 is a cylinder. Let's go ahead and sketch a cylinder. You don't have to sketch them, by the way. I'm just doing it for funsies. So we have a cylinder. This is container 2. with a diameter of 5, so that means its radius is 2.5, and a height of 6. And that's our radius. So the volume of the cylinder is pi r squared h. That's a formula you should know. They don't give you that one. They give you this formula, but they don't give you the cylinder. So pi times the radius squared times the height of 6. So it's 2.5 squared times 6 times pi. You're probably like, you didn't multiply them in the right order. It's okay. It's multiplication. You can multiply in any order. It's commutative. So the volume of this guy is about 118. So far, container 1 is in the lead. Spoiler alert, it's container 3. The cone. So let's go ahead and sketch the cone. So it's a cone with a height of 8.5 and a radius is 7.5 divided by 2. That's 3.75. So it is 3.75. So R is 3.75. And the height is 8.5. So volume of a cone is 1/3 area of the base times the height. And the area of the base is pi r squared. 1/3 times pi times 3.75 squared times the height of 8.5. Overall, I think we did pretty well on this. Times pi times 3.75 squared times 8.5. So the volume is about 125. If you did all 3 of these things and you didn't say which container, you got 3 out of 4 points. If you then said container 3, you get 4 out of 4. Okay. Next up, we're on to the proofs, or a proof. This is a coordinate proof. Again, it's pretty straightforward on proving a rhombus. So, or disproving a rhombus, which is what I say in my solution guide here. So if we're going to look at my solution guide for this, it'd be a lot easier because then I don't have to just graph it. The easiest way to disprove or prove a rhombus is to calculate all 4 side lengths, which is what I did. So I went and sketched the rhombus here. So it's MIKE. Here are the 4 coordinates of the rhombus. And then what I did is I said, all right, well, let's go ahead and using Pythagorean theorem, find the length of this side and this side. IM and KE, or IMI and KE. So I just did 2 squared plus 6 squared equals C squared, right? And then I did the same for this one. And you get radical 40 is what each of those equal. You could even write it down on the solution guide. It might be even better to like kind of go ahead and this is radical 40. This is radical 40. And then I did the same thing for I, K, and EM. I just said, okay, let's look at this right triangle. And so I said A squared plus B squared equals C squared. So 1 squared plus 8 squared, what does that equal? 1 squared is 1, 8 squared is 64. So this is going to be equal to, whoops, radical 65. And so is this one, right? 1 squared plus 8 squared equals C squared. You could use distance formula. I don't like distance formula because it's kind of hard to remember. So I just prefer just drawing in right triangles and figuring out the lengths that way. Now I have all 4 distances. You can see that the opposite sides are the same length, which proves it's a parallelogram. And then you can show that the consecutive sides are not the same. So I just said, therefore, quadrilateral mic is a parallelogram because opposite sides are congruent, but not a rhombus because all sides are not congruent, QED. I wanted to show you this again. Whoops. How are we doing on time? Oh, we're good. So for correct work to show and prove mic is a parallelogram, but not a rhombus. Appropriate work is shown, but one computation where graphing error is made, and an appropriate concluding statement is written. So if you made a mistake and your concluding so say you made a mistake and but your concluding statement is still correct, you'll get 3 out of 4 points. If you just showed it's a parallelogram and not a rhombus, you still get 3 out of 4 points. So, say you just wanted to head and calculated all 4 slopes and you showed the, opposite sides are parallel, at least you'd get 3 out of 4 for that. Yeah. So, I mean, even if you just like calculated all the distances or all of the slopes and did nothing else, you would get 1 point, right? Because here, that's what those things are saying down there. Correct work is shown, but the concluding statement isn't there. So if you just showed your work, so let's say I just did what I did here. If I just did this stuff and didn't have my concluding statement, I'd still get, half credit. So, okay. I like this question. So a park ranger basically wants to figure out if he has enough wire for these 2 trees because he's, putting in support wires for these trees. So you need to find the length of this hypotenuse and the length of this hypotenuse. So it's fairly straightforward. It's really the same calculation for both of them since we have our hypotenuse and our opposite side. So we're looking for the hypotenuse and we know our opposite side. It's going to be sine. So in this case, like for example, if I want to find the length of this side, it's just the sine of 24 equals 4 over x, right? Oh, I'm missing that. So sine of 24 equals 4 over x, opposite over hypotenuse. And then you just have to go ahead and do our calculations. So sine of 24 equals 4 over x, cross multiply, which is what I did here. And you get x is approximately equal to 9.83. Let's go to the other one. It's the same exact calculation. So here, I'm looking for this length. And so it's going to be, again, the sine of 11.6 equals 3 over y. Opposite over hypotenuse. And then you just put that over 1, cross multiply, and what you're going to be left with is this. You can get y equals 14.92. So we have the two calculations. One is about 10, one is about 15. The total distance is almost 25, so you definitely don't have enough wire. So you need to go get more wire. All right, we have like 10 minutes left, which leaves us with this amazing proof. Do we have any questions about the trig question before we move on? I think we did okay on the trig question. I'm actually curious to see what they do for the partial credit there. No is indicated incorrect. Yep. Appropriate work is shown, but one computational error is made. So if you basically found the length of both wire, wire needed, but didn't add up the total, you got 3 points. So if you just said no, that you don't get any credit for that. At least one correct relevant trigonometric equation is written correctly, but no further work is shown. So basically, if you just wrote down one of these two things, like sine of 24 equals 4 over x, or sine of 11.6 equals 3 over y, if you just wrote down one of those, you got 1 point. So again, there you go. Okay, the proof. So I'm guessing that the 6-point question will be more like a coordinate proof, like the rhombus thing we just did. And then there'll be like a 4-point triangle proof. That's just a guess of mine. I have no idea. Maybe they'll do the exact same thing. I don't know. No clue. I'm just making an educated guess. Similarity proofs. They've been coming up more often. They didn't used to do too many of these, but basically what you need to do with a proof is try and get as many points as you can. And by writing valid statements. So the first thing and so I had to prove these triangles are similar, and I highlighted them here. So I have to prove like these two triangles are similar to each other. But if you ever see an X, right, you should remember vertical angles. Yeah. If you write down that one statement here, and I used it in statement 3, you get a point. All right, that point could make all the difference. So first off, what I'm going to do is start with the given information. Quadrilateral CARI has, and I just use this information because that's all I really needed in my proof. If you're in doubt, just copy all of the given information down and just say given in your first statement. So that one's done. You're not going to get any points for that, but you'll lose points if you don't write it. So just make sure you write down the given information. Then I said quad CARI is a parallelogram. Why? Because they told me that these opposite sides are the same length. So there we go. I got 1 point for a correct relevant statement. Angle 1 is congruent to angle 2. That's these two angles here. Why? We have intersecting lines. Vertical angles are going to be congruent. Okay, then I said we think about like that Z shape, or like this is kind of like a weird looking backwards Z. Oh no, it's a Z. Yeah. It's just a kind of like slanty Z. Because we know, and I proved these lines are parallel here with statement 4, I said CA is parallel to RI. If I forgot that statement, I might lose a point, but hey, we're just trying to gain points here. So don't worry. But if you see this kind of like Z shape, you should think, oh yeah, alternate interior angles are congruent. So I encourage you to number your angles. And so that's what I said here. Angle 3 is congruent to angle 4. And then when lines are parallel, alternate interior angles are congruent. Now I know these triangles are similar. Why? If the angles are the same, and you can go ahead and you could prove, like, you could even state, like, you like name this, 5 and 6, and you could go ahead and prove those are congruent, and then you can know all three angles are congruent. That would be extra. You don't have to do that. Because once we know two angles are the same, this thing is going to be a dilation. And so what I said is that these two triangles are similar to each other. Why? By angle-angle similarity. If I did all of this stuff, I'm guessing that's 4 points out of 6. Let's see. Yes, see? So if I prove that the triangles are similar, but no further correct work is shown, you get 4 out of 6 points. So there we go. I've already gotten 4 out of 6 just by that. So I then stated that EL over EH is equal to LI over HA. Why? Corresponding sides of similar triangles are proportional. So they have the same scale factor, you could say that. And then the last one is the last thing I'm trying to prove. Why is that true? It's not sufficient to just say cross multiplication. We were going back and forth about that in the grade at the grading site. You need to actually say the cross products of proportional sides are equal. So you need to somehow say cross multiplication is just the process. So you need somewhere to say that the products of cross multiplication is equal or equal. So that's kind of what you need to state. Yeah. And we saw that in some of the examples. So I'll show you that here. If you look at the model response set. So if you look at these example proofs, and again, I encourage you to look at some of this stuff. It's all there for you. So much stuff. These are the coordinate proofs, trigonometry. Okay. Yeah, they say the product of the means equals the product of the extremes. That's another way to write that. Here's a paragraph proof. You could write it in a paragraph form. Here's a flowchart proof. You could do it that way. But I wanted to show you. Yeah, see here, this is they just said cross multiply. So they said that's not correct. So you actually need to say cross multiply. The products of cross multiplication are equal, something like that. So anyway, we have 5 minutes remaining. Are there any last minute questions you have about next week? When is the Regents exam? Let's see. Um, 12:30 on Wednesday. So 1 week from today, 12:30 in the afternoon. It means you get to sleep in a little bit, wake up, have a good breakfast, and yeah. No questions. None. Okay. All right. Well, I wish you all the best. Good luck. If you have any last minute questions, feel free to shoot me an email. Um, we are not having any sessions next week, so that gives you all of next week to work on all this stuff. There are all those resources on Google Classroom. Use them, use all the practice problems. There are 5 practice Regents exams there with solution guides, with these videos. You can go back and try them again. It's just a matter of keep practicing. All right. Anyway, again, I'll see you all in the fall. If I don't see you before, well, probably won't see you before. Stop by 406 and say hi. And good luck next week. Have a great one.